सवालों के बिना ही जिंदगी है डार्क, बल्ब की तरह जला दे क्वेश्चन मार्क।
Hi students, my name is Salim Gulabi from class 9D and today we will talk about mathematics chapter 15 circle. So let's start. First of all, starting, let's we understand what is the definition of circle. Circle is a collection of the lines in a plane, each of which is at a constant distance from a fixed point in that plane. So, have you seen the movie Sholay? Yes, of course, सबने देखी होगी. So, what were the two main characters of Sholay? Jay and Veeru. Similarly, in chapter Circle, we also have two main characters. And the two main characters are radius and diameter. Okay, so let us understand what are they two. By this diagram you have understand that Cn is equals to radius and An is equals to diameter. So let's take its formula. Radius is equals to half of diameter and diameter is double of radius. Okay, so now understand about some other terms related to circle. First is chord. Chord is a line segment joining 2 points of a circle. See, AN. The line AN is equals to chord. So let's take another term which is secant. So this is a circle. So let's check what is a secant. Secant is a line which meets a circle in 2 points. Is a line which meets a circle in 2 points. So secant is this point PQ. Point PQ is equals to secant. Some students have confusion in difference between chord and difference between secant. So you can easily see by this diagram that in a circle, this line that is inside this is called chord, and the line that's coming outside the circle is known as a secant. Okay, so now let's talk about arc of a circle. So let's take a definition. The continuous part of a circle is called arc of a circle. I repeat, the continuous part of a circle is called an arc of a circle. It has a symbol also. So let's take what is its symbol. Symbol of arc is this. Let's take an example. So suppose this is a circle, this is a point, and this part from here to here, it is known as A and N. Let's take this point at, let's take it point O. So A, O, N is equals to an arc. This part, which is highly vibrations, this is known as arc. So let's talk about two main types of arc. One is major arc and other is minor arc. So let's take same example here also. So AON is an minor arc. And ANC, I repeat, the ANC is equals to major arc. As you can see that this part is small, so it we will take it minor, and this part From here, it is a large to we will take major arc.
Some terms related to a circle. Number 1. Sector of a circle. The part of a plane region enclosed by an arc of a circle and its two bounding radii is called a sector of a circle. Number 2. Segment of a circle. A chord of a circle divides its circular region into two parts. Each part of a circular region is called a segment of a circle. Number 3. Angle subtended by an arc. Angle subtended by the two bounding radii of an arc of a circle at the center of the circle is called the angle subtended by the arc. Angle subtended by a chord. Let PQ be a chord of a circle. Let PQ be a chord of a circle with the center O and RS be the point at the minor and major arcs of a circle. Point R and point S be the point on the minor and major arcs of a circle. Join OP and OQ. Then angle POQ is the angle subtended by the chord PQ at P and Q at the center O. Number 5. Concentric circles. Two and more circles are called concentric circles if and only if they have same center but different radius. Number 6. Equal circle. Two and more circles with equal radius is called equal circles.
The theorem which we are going to study is this. The straight line drawn from the center of the circle to bisect a chord which is not a diameter is perpendicular to the chord. The figure of the theorem is this. Now we are going to start. To prove we have to prove OM is perpendicular to AB. The given things are OM bisects to AB, that is AM is equals to MB. The construction we have to make in the circle is to join OA and OB. Proof. Statements. In triangle, OAM and OMB, in which OM is equals to OM bracket common in both the triangles. They are common in both the triangles. OA equals to OB. Radii of the circle. Of the circle. The third point is AM is equals to MB. Bracket OM bisects OM bisects AB. Hence triangle OAN triangle OBN. So by CPCT angle OMA is equals to angle OMB. Let angle OMB BX. So angle OMA is equals to x. Thus angle OMA plus angle OMB is equals to 180 degree. So linear pair LINEAR linear pair. So x plus x is equals to 180 degree. So 2x is equals to 180 degree. X is equals to 180 degree by 2. X is equals to 90 degree. So hence proved. ON is perpendicular to AB.
Hello everyone, today I am going to explain you the axiom of equal arcs with the arc properties of circles. So let's start. I am going to say that in equal circles, or in the same circle you can say, if two arcs subtend equal angles at the center, then they are equal. I mean to say that in equal circles, see these both circles, these are equal, and now I'm going to label this A, B and O. It is written. These two circles are equal, guys, and in these two circles we are saying in the drawing figure arc AB. This is the arc AB and arc PQ. I am going to label this one now. The arc PQ of two equal circles having if they are equal circles, they are equal circles and also have the equal radii. Means these are this is first radius and this is second radius, and this is first radius, this is second radius, guys. So and here will be an angle and with center O and O dash. So they will respectively subtend equal angles at the center. That is, we can say angle AOB is equals to angle PO dash Q, or we can say arc AB is equals to arc PQ. And similarly in these two circles, now we are going to do the vice versa. Means similarly in these two circles, these are also the equal circles. That is AB, OAB this is, and this is PQ, and this is O dash. So in these both circles are equal, guys, and also these two arcs are equal, AB and PQ. Okay, they subtend equal angles at the centers. In our joining figure, we can say arc AB and arc PQ. Of equal circles. Arc AB and arc PQ of equal circles having equal radii, means they both have equal radius. First radius is OB and second radius is OA. Similarly in these two circles and similarly in these two circles. Radius A, OB and OA, and this also radius OQ and OP. They both are equal with center O. In this the center is O and this the center is O dash. With center O and O dash. Okay, guys. Respectively, they are equal. Means their radius are equal and these circles are equal. That means their arc will also be equal. So we can say arc AB is equals to arc PQ, or we can say angle AOB is equals to angle PO dash Q. So guys, you can also see that here we have written this only, but in the term of angles, and here we have written same thing, but in the term of arcs.
Tell you about the arcs and the chords theorem. In first theorem, in equal circles, equal chords cut off the equal arcs. Means that if angle OA is equal to angle O1P and angle OB is equal to angle O1Q and AB and PQ that is given is equal, so the angle AOB and angle PO1Q will be equal. And then in the second theorem, in equal circles, if two arcs are equal, then their chords are equal. Means that if the angle OAB is equal to angle O1PQ and if angle AOB is equal to angle PO1Q, then the chords will be equal. Means that AB is equal to PQ.
I'm Yashas Dwivedi of class 9th and I'm going to explain you some questions of chapter circle. This is the first one. This question says a chord of length 16 cm is drawn in a circle of diameter 20 cm. Calculate its distance from the center of the circle. This is the diagram. Here AB is given 16 cm, so we will take out AM by multiplying half into 20, which half into 16, which AM comes 8 cm. Then D equals to 20 cm, which is given. AO, and we will find AO by multiplying half into D, which is half into 20, and AO comes 10 cm. Then right angle triangle AOM by which is given here. See, AOM you will take out by Pythagoras theorem. AO square plus OM square plus AO square equals to OM square plus AM square, which becomes 10 square equals to OM square plus 8 square. So 100 equals to OM plus 64. OM square equals to 100 minus 64. OM equals to under root 36, and OM comes 36, which is our answer. This is the next one. This question says the center of a circle of radius 13 units is the point 37. P79 is the point inside the circle. APB is a chord of circle such that AP equals to PB. Calculate the length of AB. So we will here it is given C36 and P79. AB equals to PB means midpoint of chord. P is midpoint of chord. Now join CP. After we join CP, CP bisects AB. CP bisects AB, which is chord. Radius equals to CA as it is given here. So CA equals 30 units, then radius will also be equal to 13 units. Then we will take distance formula, which is CP equals to 7 minus 3 ka whole square plus 9 minus 6 ka whole square and whole under root. So CP equals to 4 square plus 3 square whole under root. CP equals to 16 plus 9 whole under root. After solving this, CP comes 5 units. Then from right angle triangle CAP, which is given here, CAP, which is a right angle triangle, we will take Pythagoras theorem. AC square equals to AP square plus CP square. 13 square equals to AP square plus 5 square. 169 equals to AP square plus 25. After solving this, AP comes 12 units. So as AP is half of AB, we will multiply it by 2 to get length of AB, which we can see in diagram. AB is half of AB. So AP will be multiplied by 2 to get AB. 12 into 2 equals to AB, which is 24 units. Length of AB comes 24 units. This is the third one. In the figure given below, this is the figure. The diameter of CD of a circle with center O is perpendicular to chord AB. If AB 8 cm and CM 2 cm, find radius of circle. Here AB the chord is given 8 cm and CM is given 2 cm. So here we can see CD bisects AB, means OM bisects AB. So AB is bisected at M. So given this we have given that AM is half of AB. So AM equals to half multiplied by AB. By this we will take out AM. AM equals to 4 cm. Then we will let radius be X. So OM equals to OC minus MC. OM equals to X minus 2. So from right angle triangle OAM, this is the right angle triangle OAM. This one. Then we will take out it by Pythagoras theorem. OO square equals to AM square plus OM. So X square plus equals to 4 square plus X minus 2 ka whole square. Then we will solve it and X becomes 5. So radius equals to X and X becomes 5 cm. Radius comes also 5 cm. And this is the last one. In the adjoining figure, AB and CD are two chords of circle with center O at distances of 6 cm and 8 cm respectively. If the radius of the circle is 10 cm, find length of the chords. This is the adjoining figure. So here we can see OM bisects AB and ON bisects CD. So OM equals to 6 centimeter, which is given, and ON equals to 8 centimeter, which is also given. So now join OA and OC. We will join OA and OC. Then since OM bisects AB, then AB is bisected at M. OM bisects AB, so AB is bisected at M. So it becomes AB is half of M, so AM multiplied by 2 becomes AB. So since ON bisects at CD, ON bisects at CD, then CD is bisected at N. So this also comes CD equals to 2 and OA equals to OC, which is equals to radius of the circle 10 centimeter. In triangle OAML, angle M equals to 90 degrees. So we will take out it by Pythagoras theorem. AM square plus OM square equals to OA square. AM square equals to OA square minus OM square. 10 2 minus 6 2. So it comes 8 centimeter. AM comes 8 centimeter. So AB will be 2 AM. AB becomes 16 centimeter. In triangle OCN, angle N is 90 degrees, so we will again take out it by Pythagoras theorem. Cn square plus ON square equals to OC square. So Cn square equals to 10 square minus 8 square. Cn square equals to 100 minus 64, and Cn comes 6 centimeters. So CD equals to 2 Cn. So we will multiply 6 by 2 and our CD comes 12 centimeter and our C and AB comes 16 centimeter.